Good morning, everyone, and welcome to this lecture on NFPA 400, the Hazardous Materials Code. In today's presentation, we'll take a journey through how NFPA 400 was developed, why is it important, and how it's used to keep people, property, and environment safe. My name is Captain Engineer Salma Salah Al-Buflasa. I'm a Certified Fire Protection Specialist. The origins of NFPA 400. Before NFPA 400 existed, there wasn't one comprehensive code to cover all hazardous materials. Instead, we have several separate NFPA documents. For example, NFPA 430, NFPA 432, NFPA 434, and finally NFPA 490. Each of these documents focus on specific material types, but it created confusions and duplications because facilities often store several different types of hazardous materials. In 2010, all four documents were officially withdrawn and merged into one single comprehensive document known as NFPA 400. This new code became the foundation for all hazardous materials because it brought everything together into one place. NFPA 400 also included sections for NFPA 55, which deals with compressed gases and cryogenic fluids, and it also introduced one of the most important concepts, the maximum allowable quantity, or in the MAQ. The development of NFPA 400. Like all NFPA codes, NFPA 400 evolves over time. Each edition builds on experience, research, and real-world incidents to improve safety. For example, in 2013, NFPA 400 updated its MAQ tables and aligned them with NFPA 55 to make sure both codes were consistent. In 2016 edition, it improved requirements for ammonium nitrate storage. And 2019, the code reorganized and simplified its tables. And 2022, Chapter 14 was revised to include new and cleaner information about organic peroxides. And finally, 2025 edition added a new definition for ammonium nitrate emulsion and harmonized oxidizer classification with OSHA requirements. Each update reflects lessons learned from real incidents. To apply NFPA 400 effectively, you need to understand how the code is structured. Chapter 1 sets the administrative foundation, including the scope and requirement permits, HMMP and HMIS documentations. Chapter 2 lists other reference standards. Chapter 3 provides all the key definitions that's needed throughout the code. Chapter 4 is the classification of hazard classes. Chapter 5 focuses on storage and use locations. And Chapter 6 defines the requirements that apply when you exceed the MAQ. Chapter 7 discusses emergency planning procedures. Chapter 9 introduces security measures to prevent theft, misuse, or sabotage of the hazardous materials. And Chapter 11 till 21, it goes deeper into specific materials such as oxidizers, peroxides, and ammonium nitrates, explaining their particular storage and safety rules. And finally, the annexes A to L. At the end of the code provides helpful guidance, charts, and additional explanations that are not mandatory, but extremely useful in practice. Administration. The applicability of NFPA 400. NFPA 400 applies to all facilities and occupancies that store, handle, or use hazardous materials in quantities that could pose a risk to life or property. This includes manufacturing plants, laboratories, warehouses, hospitals, and even schools. What should it apply to? The ammonium nitrate, both in solid and liquid, corrosives, flammable solids, organic peroxide formulations, oxidizers, ferrophoric, toxic and highly toxic solids and liquids, unstable reactives, and water reactive solids and liquids, and finally compressed gases and cryogenic fluids as included within NFPA 55. However, the code also includes a number of exemptions. It does not apply to small quantities of hazardous materials used in private dwellings, explosives and blasting agents, which is governed by NFPA 495, refrigerants and oils in closed cycle systems, high hazard contents for on-premises agricultural use, corrosive materials, aerosols complying with NFPA 30B, corrosives in original packaging, ignitable liquids with no other hazard properties, organic peroxides per NFPA 495, combustible metals, LP gas, approved materials shown not hazardous based on the quantity and condition of storage, and off-site transportation as per DOT regulations, and satellite nitrate film complying with NFPA 40. I've mentioned the HMMP and HMIS requirements before. What are those? The Hazardous Materials Management Plan is when required by the AHA in new or existing facilities that store, use, or handle hazardous materials covered by NFPA 400 Chapter 5 in amounts above the MEQ shall submit a Hazardous Materials Management Plan to the AHA. It's actually a written plan that describes the operation and safety measures in one place for handling and storing hazardous materials. It also includes the layout of storage rooms, emergency shutoffs, and fire control systems. And the plan must be updated annually, or when the facility is modified, or where hazmat represents a new hazard category not previously addressed or stored, used, or handled in the facility, and it must provide narrative description of the operations. For example, here a picture of the NFPA 400 Annex or HMMP. We have the facility description, general facility description such as the site plan, the storage map, and in section 2 we have the hazardous materials inventory statement. It's actually the second key document in the code. This is essential as a detailed list of every hazardous materials on site, including the name, chemical composition, hazard class, case number, quantity, and storage conditions. For example, if a chemical laboratory stores 800 liters of nitric acid, it must list it as corrosive and oxidizer. And an updated HMIS must be submitted within 30 days. An amended HMIS must be provided within 30 days of the storage of any hazmat that changes or adds a hazard class, or that is sufficient in quantity to cause an increase in the quantity which exceeds 5% for any hazard class. And we have the key definitions in the code. First, what is a hazardous materials? It's any chemical or substance that poses either a physical or a health hazard. What is a physical or a health hazard? First, the health hazard is a chemical or substance classified as toxic, highly toxic, or corrosive material. And a physical hazard is a chemical or substance classified as an explosive, flammable carcinogen, flammable gas, flammable solid, anything that causes harm physically. And we have the incompatible materials, the materials that, when in contact with each other, have the potential to react in a manner that generates heat, fumes, or gases. For example, in the DOT classification, we cannot store oxidizers with flammable liquids or flammable gas. And we have the most important definition, the MEQ, the maximum allowable quantity per control area. It represents the maximum amount of a given hazardous material that can be stored or used with a control area before additional safety measures is added. And we have the protection levels. It refers to the additional layers of a building protection and design that apply once the MEQ is exceeded. And we have the control area. It's defined part of a building where hazardous materials can be stored safely up to the MEQ. It should be not exceeding the maximum allowable quantity. And finally, we have the DOT. It's Department of Transportation in the United States of America. And Chapter 4, Classification of Materials, Waste, and Hazard of Content. As I mentioned, DOT has its own classification. It uses a 9-system classification method broken into divisions. For example, 1.1, 1.2 explosives, and 1.3 whatsoever. So Class 1 explosives are the materials that could detonate or rapidly increase energy, such as TNT, fireworks, or blasting caps. And Class 2 dangerous gases includes flammable, non-flammable, and toxic gases. And Class 3 has the flammable liquids that can produce flammable vapors, such as gasoline, and we have them in NFPA 30. And Class 4 is dangerous solids, such as magnesium and phosphorus, solid that ignite easily or react with moisture. And Class 5 are oxidizers and organic peroxide, such as ammonium nitrate. And Class 6 is toxic and infectious substance, such as medical waste. Class 7 radioactive materials, such as uranium. Class 8 is corrosive substance that can destroy tissue or metals. And finally, Class 9 is materials that do not fit elsewhere but still pose a risk, like lithium batteries and dry ice. This system ensures that every material transported by road, air, or sea is properly labeled, packaged, and handled according to its risk category. But in NFPA, we have our own classification. It's the 14 classification categories. We have the corrosive solids, liquids, and gases, flammable solids, flammable gases, flammable cryogenic fluids, inert cryogenic fluids, inert gases, organic peroxide formulations. We also mentioned this at the beginning of the lecture, oxidizer solids or liquids, and till the end. This system is more detailed than the DOT classification because it directly links to the fire protection, ventilation, and also containment of the materials. And we have the high hazard contents. NFPA 400 group materials into 4 hazard severity levels called the high hazard level. Level 1 materials present detonation hazard. They can explode like detonable peroxides. And level 2 materials that present deflagration or fast burning hazards. These include flammable gases and combustible dust. Level 3 materials that are combustible or present a physical hazard, such as flammable solid or oxidizing gases. And level 4 is materials that are acute health hazard substances that are highly toxic or corrosive, such as chlorine gas. Each level defines the building fire resistance, explosion venting, and separation requirements. Chapter 5, permissible storage and use locations, introduces us the control areas. As per NFPA 400, hazardous materials shall be stored and used in any of the following: in control areas complying with Section 5.2, in occupancies complying with requirements for protection level 1, 2, 3, and 4, and finally in outdoor areas complying with the Section 5.4. What are the protection levels? When hazardous materials in quantity exceed the MEQ, facilities must apply the concepts of protection levels, which range from level 1 to level 4. Protection level 1 corresponds to detonation hazards where required the strongest construction features, including reinforced walls, blast-resistant doors, and explosion vents. Protection level 2 is for deflagration hazards. That includes heavy-duty ventilation and separation systems. Protection level 3 applies to materials that readily support combustion. And protection level 4 is for acute health hazards, such as corrosive and toxic materials that require containment and ventilation system to protect personnel. Each level ensures that as the hazard increases, the level of safety and engineering control increases proportionally. And the most important thing in the code itself is the maximum allowable quantity based on the MEQ. Determining MEQ is one of the most important steps for any facility using hazardous materials. In order to read table 5.2.1.1.3, there's the material, the class of the material, the high hazard protection level, the storage if it's in solid pounds, liquid gallons, or gas, and the use of it in closed systems or open system. So how do I use the table? We identify the hazard material category from the 14. We determine the storage versus use, open or closed system. Open is more restrictive. We find the base MEQ, and then we apply footnote A and B. What are footnote A and B? These footnote A is for the sprinklers, and footnote B is for the permissible storage or the approved cabinet. So let's say, for example, I have a base MEQ of 16 kilograms. The sprinkler might add it to double it till 32. And again, if I have the approved cabinet, the 32 will be also doubled to 64. To clarify it, for example, if the building is sprinklered, you may increase the MEQ by up to 100%. Add the total quantities in each area and ensure they do not exceed the allowable limits. If they do, the building must upgrade to higher protection level. These calculations are essential for design, approval, and inspection of facilities. And I have the construction requirements for control areas. For every floor level, the maximum allowable quantity will decrease, and the number of control areas per floor will also decrease, and the fire resistance rating for the fire barriers will increase. For example, if I have my 64, which is the 100% per area controls in the first floor, and the third floor it will be halved. So yeah, to wrap up our lecture, let's summarize the key points. NFPA 400 brings together multiple order codes into one unified document that manages the safe storage, handling, and use of hazardous materials. The DOT classification system focuses on transportation, while NFPA 400 focuses on building safety and design. The concept of MEQ, control areas, protection levels are the foundation of fire and life safety when dealing with chemicals and reactive substance. And this is just an introductory presentation. And for the future, would go venture deep into the code itself. And thank you so much.